Welcome to the lectures on problem solving and programming in C. This is lecture 31 and the title of the lecture is multidimensional lists or arrays and matrix operations. So far we have seen how to declare, how to read, write single dimensional array which is of single dimension. Now see if you want to perform operations on matrix are two dimensional. There are rows and columns. So how do we declare such a two-dimensional or multi-dimensional list? And how do you operate on them? How do you read elements? How do you write elements? How do you perform operations on such lists? We will see in this lecture. Yes. So in this lecture, what we will learn is first we will focus on two-dimensional arrays. How do you declare? Suppose if you want to declare a single-dimensional array, you will say int m of 10, right? This will be a. If you ignore this second dimension, it will be single-dimensional array. So suppose if you want to declare a two-dimensional array of 10 rows and 10 columns, you need to declare something like this: int m 10 and 10. So in brackets 10, this is the number of rows and this is number of columns. Then this lecture, what we will do is I will show how to read and write two-dimensional arrays, and then we'll also perform matrix operations, addition, subtraction, transpose. Okay. Let us go to it. So let us say algorithm 2D arrays, 2D array. In this input n greater than 0, comma m greater than 0, n by m matrix we are looking, and elements of n by m matrix. Okay, so we'll read n and m values and followed by the number of elements. Output display the red matrix elements. Okay, begin. This algorithm is just to read elements of a matrix and then just display them back. Okay, through this we will learn how to read multidimensional array and how to write display the data of a multidimensional array, two-dimensional array basically. So input put n comma m. Okay, we are reading two values n and m, number of rows and number of columns. So input validation, if n is less than or equal to 0 or m is less than or equal to 0, then output invalid input, because the dimensions cannot be 0 or negative, no? It input. Then stop. And if. And if. Next. So how many rows we need to, basically if the matrix has n rows and m columns, how many elements are there? Total n by m columns. So that's why we need to declare the matrix. Matrix n dimensions, n dimensions. Let's say matrix is A. A matrix is A. A is the matrix. N dimensions, m rows, m column, n rows and m columns. Okay. So how many rows are there for I equal to 0 to n minus 1? Do. Then for each row there are m elements, column values. So for j equal to 0 to m minus 1, do. Input a of I comma j. Okay. And for this is a logic which we use to read the matrix elements of dimension n by n. This is for declaration of the two-dimensional matrix. If you want multi-dimensional matrix, A of 10, 20, 30, like this. This is three-dimensional matrix. So one dimension is 10, another dimension is 20, another dimension is 30, like that. We can have multi-dimensional view, but I think most of the applications we just need we cannot. I mean, most of the applications requires two-dimensional matrix only. Okay, so that's why we restrict our discussion to two-dimensional matrix. Now let us display the matrices back to the user. So so for I think I can copy this back again. Since we need to display the matrix elements output matrix elements are matrix elements. Okay, so this should go over to output. This should be output. Okay, of course we need to display them in row as a matrix format. For that we need to add spaces, add new line symbols and all that we will do in the program end. Okay, this is the problem. This is the algorithm. We have read the dimensions of the matrix and validated the dimensions. Then we have declared a two-dimensional matrix, two-dimensional list. And then we have read the elements using a nested repetition because the number of rows is n, and in each row there are m elements. That is why we need a nested repetition to read the elements. Similarly, to display the matrix also we need a nested repetition. Let us do this using the matrix. Hash include stdio.h int main return default 0. Then input n m, right? So int n comma m printf, enter the dimensions of the matrix, scanf %d comma ampersand n comma ampersand m. Okay, next input validation if n less than or equal to 0 or m less than or equal to 0. Then invalid printf invalid input. And then stop. Okay, right. Next, what next? Then we need to declare the two-dimensional array, right? So int a of n m. This is how you declare a two-dimensional array of n rows and m columns. Then followed by we need to have a nested repetition to read the elements. Printf enter the matrix elements for int I is equal to 0, I less than n, I plus plus, right? For int j equal to 0, a less than m, j plus plus. Printf enter the matrix element, and %d. So we are displaying in a format. Then scanf This is a message to inform the user that which matrix, which row and which column element we are trying to enter. Okay. Of course, we enter the row 0 elements first and then row 1 like that. %d ampersand a of I j. This is how you read a matrix element, single matrix element. After that, we can display the elements like this. Cat. So I need these statements. Matrix elements are the matrix elements are the matrix elements are right \n. So we need to display the matrix element followed by space. Then after each row, there should be a new line, right? Because each row should be displayed in a separate line. This is what. So this should not be ampersand here. This should be printf. Insert printf %d a of ij. That's it. Right? GCC matrix compile. Let us say 3 and 3. Dimensions of the matrix are 3 and 3. Matrix 0, 0. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my matrix. The first row we have 1, 2, 3. Second row 4, 5, 6. Third row 7, 8, 9. This is how you read elements of the matrix one by one. Okay. Let us try to understand. Suppose if you have two matrices, how do you perform addition of two matrices? How do you perform the transpose? So let us say this is the matrix. I want to display the transpose of the matrix. Okay. I will just display. So what we need to do is we just need to display how many columns are there. So basically if number of rows is m and number of columns is m, the matrix, the transpose will have m by n columns, right? M rows and m columns. So let's say m rows, m rows and n columns, right? I display ji. So let us say this is a matrix. We will display the transpose here. The transpose of the matrix. Transpose matrix elements are. Okay. So this should be number of rows should be m, number of columns should be n, right? And then number of rows. This should be j I. Okay. Ji. Let us see what happens. Slash a 3 by 3. Let's enter 3 by 3 matrix. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You see here The original matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. See the transpose matrix, the elements are reversed 1, 4, 7, 2, 5, 8, 3, 6, 9. This is how you can compute the transpose of a matrix. Okay, because the transpose, the number of rows are m. Okay, the number of columns are n. Then original element ij will become a ji in the transpose matrix. That is why you should display like this. This is a technique to display, create a transpose of a matrix. Yes. How do you create a matrix? For example, imagine you have read two matrices A and B. Okay, A, B, A of 10, 10, 10. B of 10, 10, 10. Okay, or else A of n, m. B of n, m. So imagine to perform addition or subtraction, the number of rows and columns has to be same. Otherwise, we cannot do addition. What we can do for I equal to 0 to n minus 1, do. For j equal to 0 to m minus 1, do. Okay. So C of ij, j is equal to C is the addition of the a plus b equal to a plus. Suppose if C equal to a plus b, what you can do is equal to a of I comma j plus b of I comma j. This is how you can create some of the two matrices. Okay, each element corresponding element is added to create the sum matrix. Let us incorporate this in the program. We have displayed the transpose. So what we can do is we will we can even what we can do is we will read another matrix. We can read another matrix. So this entire portion we will copy. One matrix is our matrix elements, matrix A elements. A elements. After that, paste matrix B elements. B elements. B elements. Okay. Here should be B. Right? Two matrices are displayed. So this we have displayed matrix A. Let us display matrix B also. Matrix A elements. Matrix B elements. Here it should be B elements. Then transpose of transpose matrix of elements of A, transpose of matrix A. Then what we can do is we will display the sum. C will be int C, matrix C of n m. This is the matrix C. Okay. So what we can do is we'll sum up the elements. Insert C of I j is equal to A of I j plus P of I j. Okay, this we can remove. Right, this makes the addition of two matrices. And then we can display the matrix. The matrix C elements are. Matrix C elements are. Here just we need to display C. Let us run this. This is the matrix. Compile elements of the, let's say 3 by 3. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Matrix B elements, let us take reverse 9, 8, 7, 6, 5, 4, 3, 2, 1. What is the element? See, this is the matrix A, this is matrix B, this is the transpose of matrix A, this is the sum of the matrix AB. See, you see here 1 plus 9 is 10, 2 plus 8 is 10, like this. The addition is correctly performed. Like this, you can do subtraction. For the subtraction, only thing is instead of plus here, you will have a minus symbol here, right? Minus symbol. Like this, we can do a matrix operation. Whenever you are talking about matrices, we need the nested repetition. To perform addition, to read elements, to display elements, we need nested repetition. Okay. Right. So that is about matrix operations. Addition, transpose you have seen, subtraction, addition is seen. See, all these functions can also be done as a separate functions also. This matrix operation can be done as a separate function. For example, suppose if I want to perform addition of two matrices, what I can do is I can write a function. Write a function like this. Int void. It doesn't return anything. Matrix add. What we need to do is int a n comma int m comma int a of n n m. Okay, this is the first matrix. Int b of n m comma int c of n m. So in this, inside this, what we can do is we can perform addition of a and b and store it in c. Okay. So whoever calls this function, he will get it passes three matrices A, B, which are already read. C is uninitialized matrix. C, and then after the call, C will contain the sum of the matrices A plus. Okay. Like this, each function can be written as a separate function. Each functionality of matrix can be written as a separate function. Right? I'll stop here. Thank you.